Sorry.
It's all right. Hey everyone, thanks for joining us for first meeting of 2023. We have 1Spatial here to talk with us about some products and stuff for us to learn about. So here's Kevin Sigwart.
Yeah, thanks, Adam. So hi, everybody. Yeah, I'm Kevin Sigwart. I'm the Chief Operating Officer for 1Spatial Inc. At 1Spatial, we focus on data management solutions, and one of the data sets that we work with quite a bit is CAD data. But it's not just limited to CAD data, and we'll talk a little bit about that throughout the presentation. So what I figured I'd do, I'd kind of introduce, why people care about data quality, and then we're going to go into who 1Spatial is, how we help organizations with those types of issues, and then go through some real actual use cases of some of the work that we've done in the past related to AutoCAD. So I do like to keep this interactive, and it is a fairly small group. So if you guys have questions, feel free to jump in and interrupt me. I don't have to be lecturing for a whole hour. I'm more than happy to take questions. So feel free to jump in and ask any questions. And that includes the 1Spatial folks. Sheila, if you want to jump in and interrupt at some point, go ahead and interrupt me.
I will.
I'm giving you permission to do so. Even though
it's funny because I will anyway.
Exactly, right. So I'm going to start this off with a little survey. And some of you are sharing your screen, so you can raise your hands if you for these different things. Or you can also use the whatever they are, the annotate things on in Zoom to share which ones you agree with, right? So, what really excites you about data? I have three options here, right? Is it the insights and the information that it can provide the business? So, getting the information from that data. Is it the ways that it makes your business operations more effective and efficient? Or is it the cleaning and the maintenance of the data? Now, right? Yeah. As somebody that has been working in the field of, and just for everyone to know, my background is, I have a pretty significant background in working with geospatial GIS data. And in doing so, I've spent my fair share of time going through and having to clean and massage data. Sheila mentioned that, you guys might have you might have been listening in when you first joined, but Sheila used to work for Esri, and I did too. And as my role for Esri, I was a solution engineer, and I had to go and I had to massage data in order to get it to work in the Esri applications, because nothing you ever got right off the street worked in the application. You always had to clean it up and massage it. So I would say before I could do a presentation or demonstration, I'd spend 2 or 3 weeks just getting the data cleaned up in a way that I can do the analytics against it to demonstrate the software. That is standard, not just for doing demonstrations. That's standard for when you're actually trying to analyze the data in your own organizations. So what we found is, or what organizations have discovered, is that employees spend 50% of their time dealing with just managing the data quality of their data, and according to Gartner, 80% of data scientists are spending their time, or data scientists spend about 80% of their time in the cleaning and organizing your data. And I'm sure we have all had to deal with this. You want to do some sort of analysis against some sort of data set. You get the data, you have to clean it up, massage it, then you can run the analytics. Then what happens is you probably take that data set and you put it aside. Somebody else wants to run some sort of analysis against the data, and they're going to do the exact same thing. So repeating to do this is just wasting a lot of time and effort when we just want to get our answers to our data. So at 1Spatial, we try to help organizations relieve some of this pain through automation. And we do that through automated data management solutions. So at 1Spatial, we work in a number of different industries. For example, in government, we work with a lot of large national government agencies like the U.S. Census and Federal Highways and USGS. And all the way down to the local level, all the way down to local governments like LA County, or even smaller jurisdictions in LA County. We also work in transportation, working with the organizations like Caltrans and Arizona DOT, and and a variety of other ones. You can see them here. In facilities management, one of the case studies I'm going to highlight today is the work that we've done for Google with their Real Estate Worldwide Services Group. So we'll talk a little bit about that. But then we also do work in utilities too. I don't have a little sector here for that, but we also do a lot of work in utilities also, helping them with solving these data management, some of their data management problems. And we do that through our technology, and our technology focuses on these three main aspects of data management, and that's data validation, data integration, data enhancement. So we have some products and some technology that is it's called 1Integrate. I'm going to talk about that in the next slide, but it provides a way to automate the process to do data validation. For any of those that have worked with data and worked on validating it, doing it manual is very time consuming. It's also very subjective. So having a way to automate that process of validating the data can really get you to a better place with identifying where those issues are with your data, and also helping you cleanse that data set up if you know where those issues are without having to go and search for those issues. Our technology is also data agnostic. So here today, we're here to talk about AutoCAD or CAD data sets. But we are, as I said, we are data agnostic. So we work outside of just working with CAD data. We work with organizations that work with GIS data. So all your Esri formats or your open OGC standard formats. We also work with just database technology, whether it has geospatial data sets or not, like your Oracles, your Postgres, and your SQL servers and so forth. And what our rules engine can do is it can connect into these sources of data and write business rules or validate the data against business rules against all those different data sets. So, and the example that I'm going to talk about in a little bit with Google is that we can start looking at their AutoCAD drawings, but compare some of the information in the AutoCAD drawing with their asset management system, which is IBM Tririga. So being able to connect to both of these systems, bring it into this validation engine and validate the data. So you're validating the data truly across the enterprise, as opposed to looking at individual systems or just individual silos. And then lastly is we also do automate the process of doing data cleansing. So when we identify an issue, we can also identify business rules to auto cleanse the data. This can be just fixing, like snapping features together, snapping objects together. It could be inferring where assets should be based off of other information surrounding that data, and so forth. So like doing that data cleansing process. And we do that through two pieces of technology, through two main pieces of technology. Our 1Integrate technology, which is that rules engine. Over here on the left-hand side of that diagram, you can see all the different formats that we support. And this is a growing list. We're continuing to support new formats, but we can connect into those different systems. It pulls it into the rules engine. It runs these validation checks against the data, and it's gonna write out results, information results. What some of the unique capabilities of this rules engine is, one is that it's fully configurable. You can configure business rules in the engine using a user interface, and I'll show that in a little bit. It also has some unique capabilities for the way that it handles data. So it's going to take in that data and it's going to actually write that into this under the hood, this object-oriented database that enables it to index very uniquely the geometry information and the attribution in a way to do quick feature-to-feature transactions. So what this enables us to do is handle very large, complex data sets in a very performant way. So you can chunk through lots of data in a very performant way. Then we have another piece of technology called the One Data Gateway. And what this enables you to do is to provide basically a data portal for users to submit data to be validated and to be integrated. So I'm going to show you a really good use case of this very shortly with the Google use case and how it's being used. So with that, just one more slide, and then I'm going to get into more of the use cases and so forth. We typically package our technology together to support data supply chains. I'm an organization. I'm collecting data from either contractors or localities or other people in my organization, and I want to provide a way to get that data, make sure it's correct, and integrate that into some sort of central database repository. And we help with automating all those different pieces. So from the place of where they're collecting data from data contributors, validating the data, identifying if there's any sort of issues with that data, writing out the results to give those groups of individuals that are actually writing that data to know where those issues are at, providing a way for them to, when they submit data, to, once it passes the validation checks, to go through the integration process, and then integrating that into some sort of central database repository. So let's get to now the actual Google use case that I was referring to. So we are doing work for Google's Real Estate Workplace Services Group. And one of the challenges that they had was with their CAD data, their asset supply chain with their CAD data. And basically they went through this sort of process. You have engineers that are going and they're creating these AutoCAD drawings of building floor plans. And those drawings are being used for a variety of different systems. One of those systems is it needs to go into a TriRiga database, which is an asset management system for managing people and places. And in order for it to get into that system, the data needs to be formatted in a way that the system can read it. So the format that TriRiga is expecting the data to be in. And it also has to meet a certain set of data quality standards. If it doesn't meet those data quality standards, it could just get rejected when it's trying to go into the system, or it may even just like it goes into the system and nobody even knows, but there's some weird issue and it's causing some sort of downstream effect that doesn't get noticed until the end users are accessing the data. So this process before Google came to us was extremely manual. Every single piece was done by contractors and individuals working through it. And whenever you have just people working on things, there's potential issues that can occur. So, for example, the contractors that were like validating and cleansing the data in order to go into TriRiga, they would find that there was an issue with one of the drawings. When they found that there was an issue with the drawing, they'd have to go back and send that data back to the engineer. And likely the engineers that were actually developing these drawings are long gone. Like they already submitted the data, they're done. They might not be even under contract anymore by the time it gets to this organization. So this can really delay getting data into their asset systems. Another issue that they find is that the data makes it all the way through, but then the end users are using the data and they find some sort of issue. And then in doing so, by the time the end users get access to the data, you're starting to lose that trust and credibility with the stakeholders. And this was actually happening at Google. One of the examples that our key stakeholder at Google brought up to us, actually brought up at our Smarter Data, Smarter World conference, was that she had one of her staff members or contractors submitted a data into the TriRiga system that happened to be like the measurement was in inches instead of feet or something like that, or it might have been like millimeters instead of meters. And basically their square footage of their asset inventory just literally went up in order of magnitude. So all of a sudden in their asset management system, it's saying that they have this amount, they have an increase in magnitude of assets. And they're like, what just happened? What is going on here? And it was all because one drawing happened to go from meters to was submitted in millimeters when they thought it was supposed to be in meters. That just increased the square footage significantly of all their entire portfolio. Needless to say, that's when they realized that they need to come up with a better way of doing things as opposed to just doing this all manually. And that's where they start working with us, and we're working with them on automating the process where the engineers are working with the data. They can submit the data into this data portal to validate, to make sure that it is meeting the business needs of Google defined by their business rules. If it doesn't, it can get rejected, and then the engineers can go back and work on formatting it in a way that is to the Google specification. The same thing goes for the contractors that are working on validating and cleaning the data for TriRiga itself. Goes through that same process. The TriRiga system can also be validated, and then all this information is then being reported out into a central database or a BI system like Google BigQuery. And the reason why we're doing that is that so then you can have oversight and seeing, well, what is the state of the data currently, and where is that quality going over time? So once we know what the issues with the data is, are we starting to correct these? Are we getting better quality data through doing this process, through this automation, and really understanding what risks there are in your data sets? So with that, I'm going to show it. Now, I'm not going to show you actual Google data because I'm not allowed to, but I'm going to show you a similar set of data that is a similar like data set, and we're going to run some example validation checks. Now, keep in mind that some of the validation checks that we're doing for Google are a lot more complex than what I'm going to show you here, but this just gives you an idea of at least how the platform works. And I can go into a little bit more detail on some of the validation checks that we're doing for Google also, as I'm highlighting some of these things that we're doing here. So with that, I'm going to show you a floor plan. So here's an example of a floor plan that we're going to validate. That's in an AutoCAD. It's a DWG file. And what we want to do is we want to validate the data to make sure that it is meeting a particular standard. Does it have the proper information? Is the data on the right floors or the right levels, and so forth? So what we're going to do is we're going to come into the application. So this is that one data gateway application that I mentioned before. And I am a contractor for Google, and I'm cleaning the data up, and I want to see, okay, did I clean the data up? Is it ready now to go into the TriRiga system? So I want to validate the data and make sure that that is the case. So I'm going to come in here. I'm going to say, okay, well, I'm going to run this set of validation checks. I'm going to go ahead and start my submission. I could drag my data set here. Bear with me. It is behind my Teams window, which is always challenging. Okay, here we go. And I'm going to drag and drop this data set in here. I'm going to hit continue. And then what it's going to do is it's going to look at the schema or the schema of the actual AutoCAD drawing, like what layers or levels are inside that drawing, and does it match the schema that what the TriRiga system is looking for. So we can look at the classes, and then there's also just, in this case, just geometries. There may be also other metadata associated with each individual object and so forth that would also can be highlighted here. What this enables organizations to do also is that they maybe managing the data slightly different than what the standard is, but we can map the data to that standard. So for example, in this data set, the layer, instead of being labeled as room, is labeled as RM $. So you can map that to that schema. So you don't have to necessarily maintain the data in the exact same schema. You can map that schema and then run the validation checks against it, and then also do some sort of translation, community translations.
Hey, Kevin, Ishka has a great question in the chat.
Oh, I'm sorry. There's eight things in the chat. Nobody said anything. Okay, sorry.
So he assumes that this is running on top of an FME server with the workspaces running in the background.
No, that is not true. Okay, so let me go back. So our technology, one integrate, while we do partner with FME and Safe Software for some of our data store support, we don't necessarily have to have FME server. So the technology itself, and I'll show you a little bit more of the one integrate rules engine in a second, but we have this concept of data stores, and some of the data stores are supported through FME libraries, but a lot are supported just through out-of-the-box functionality. So it is not an FME workbench that's running behind the scenes. I am showing FME here and looking at the AutoCAD drawings, and that's just because I don't have a license of Autodesk here. Is there any other questions that were in that chat window, Lillian? Or you're tracking it though, right?
Yes, I am. So far, okay. That's a good question. Ishka, did that help?
There was a thumbs up, right?
Okay,
cool.
Great.
Okay, so then we can, if you're doing schema mapping, you can save that schema and reuse that schema. And then we're going to click continue. And then what's going to happen is it's going to actually start processing the data. So it's going to pull that data into our rules engine, and our rules engine will then run the validation checks that have been configured to run against this particular data set. So some of the checks we're going to be doing are, we call them our essential geometry checks. So these are checks that we run on like GIS data. It also works really well for AutoCAD. Some of the same issues that you find in GIS, we also find in AutoCAD. So things like duplicate features, duplicate vertices, and things like that, overlapping features, so forth. So we are identifying to the contractor who just submitted this data, they're seeing instantly whether or not their data is actually meeting the standard. Is there quality issues with their data set? We have more specific validation checks, like making sure that the doors are contained within rooms, making sure the rooms are closed polylines, making sure the rooms are contained within the gross area, things like that. We can also fix issues too. So we can auto cleanse the data too. So while we may have some issues, we can say, well, some of these we can just fix automatically. We don't have to worry about sending them to the end user. We can just say, we'll just clean these and give back out a clean data set. So we can run some functions to clean the data, and then we can rerun the validations to see like, well, what's remaining with what quality issues are still remaining after we did the cleansing. So once we do that, we can then download a report identifying either a clean data set. We can download the clean data set, or we can download where are the remaining issues that I need to address with the data set. And what we can do is we can provide them the same format that we provided that you submitted the data in. So if you're working in AutoCAD, we could send you back a DWG file with where those issues are at. So we could drive the user exactly to where those issues are at, and they can start correcting it in their system of choice. So that could be AutoCAD, it could be GIS technology or whatever you're using. So for example, in this case, if I open this up, I have this markup layer that I added in here. It's going to identify what issues are in the data set. So for example, here's where it's identifying that there's some sort of gap. And then you could see if we turn on the rooms, that there is a gap in the room here at this location, which is why it's being flagged as a gap. So as part of this, so as the end user, right, as the contractor, I'm getting that instant feedback. I know right away whether or not the data is going to meet that standard. I don't have to wait for somebody to review it to tell me that there's an issue with the data. I'm getting a report that helps me actually clean the data set. As Google, I'm also getting the metrics. I know that my contractors are using the system, what they're using. I know that I can also see how the quality is trending over time with the data that they're working with. So if I come over to, as the engineer, as the individual, I can see, okay, well, how often am I submitting data? How is my data conforming over time? But then if I go back to for Google, I can see, well, who's using the system? I can see, well, which contractors are like, how is the contractors performing in general on like the data quality? Are they improving? Are they sending me data? Like, I understand that they're going to use the system to validate the data and make sure that the data is meeting a standard. So there's going to be issues. So but like, are they submitting data for completion that is not meeting the standard? Those types of things are what we're looking for. And if you have certain contractors that are underperforming, that's good information to know. Especially when you're re-upping the contract for future years, things like that. So getting that information. So let's go back to that. Now, what is going on under the hood of this particular technology, right? So we just showed the front end interface as the consultant or the contractor that's doing the data cleansing. But what does this actually look like under the hood, right? And this is where we go into our OneIntegrate rules engine. So before we were in One Data Gateway, now we're in OneIntegrate. This is the rules engine that has been configured to run the business rules and set everything up, right? So this is broken into a variety of tabs. Here I have my sessions tab. So the sessions tab is basically where I configure what I want to run. Like, what type of data set am I going to be working with? What's the expected schema of that particular data set? What do I want to write out? What type of rules do I want to validate the data against? And so forth. So that's, there's a question, I think. What level of effort upfront computer uses? Great question, Sarah. So let's take a look at that. You led me into that one, right? So let's take a look at what authoring rules actually looks like. So I'm going to select a rule here. Oh, it would have helped. I got logged out. Bear with me. Okay. All right. Where was I at? I got to find that. Okay, there we go. All right, so here's an example where I'm saying, that's not a good example. Let's see here. Okay, here's an example of a door. Okay, a door being within a room, right? And what I'm going to do is I need to set context. So just give me a second. I'm going to select the CAD data that I'm validating against. Okay, so this is how the rule authoring process works. I'm saying for a given door, there's exactly one room where the door geometry is contained within a room. All of this is interactive. So I can configure the business rule to be, I can choose the spatial relationship that I want to choose. I can choose what data sets I'm looking at. So like in this case, I'm looking at the door and I'm saying there's exactly one room. I could change that to saying, given the exterior hard wall, maybe instead of contained within, I'm going to say it's touching, so you can change the relationships, the spatial relationships. You can change, you can also, if there's attribution in here, you can also do attribution too. You can look at the attribution of the metadata. In this case, I don't really have any metadata associated with these particular objects. It's just the geometries themselves. But if you're working with like a geospace, like some of you may be working also in GIS data. If you have like a bunch of metadata or a bunch of attribution associated with a record, you can also use that in the validation checks as well. All right. So, and then back to that, the question about like the FME server and so forth. So here we have data stores. This is the different data formats that we support. So you can see here we support a number of formats. Some of these we support out of the box. Some cases we use third-party libraries like FME or other libraries or GDAL libraries and so forth to support those. So we support a whole host of formats, and FME server is one of the ones we also support. But keep in mind, this is just what we're doing really is just getting the data and bringing it into our rules engine. So we're just using it to translate the data into our rules engine. And everything else is happening inside of our rules engine itself. Yeah, I think that's what I wanted to show with one integrate, one data gateway for now. And I'm going to go to another use case, unless there's any other questions regarding this particular, the Google use case and that one integrate, one data gateway technology. There is. Lily, do you want to field the questions or do you want me to?
I'm happy to field the questions. Ishka asked, so does this work only on AutoCAD legacy data? What about Civil 3D or Open Road Designer type data sets? Format is supported as a DWG or DWN, but it does account for legacy data only or AEC data too.
All right, great. All great questions, right? So we use the open libraries for supporting DWG, DGN, and so forth. So as long as those libraries are supporting the updated specs and so forth, it will support those formats. When it comes to like 3D, we are adding new data stores to support BIM models and so forth. And I actually have some slides on that in a little bit too about on the 3D side of things and the BIM side. Because that typically comes up when you're talking to a CAD user group. So I will get to that in a few minutes on the BIM side.
You're on the right track, Ishka.
Kevin, I got a general question, and
Sure.
maybe this is a little outside of what you're talking about, but I was looking at your client list on the left, and it made me think about something in particular. The TxDOT transportation road network system is bad. Ken's laughing. They've employed a vendor to use some 2D AI processing to at least give us the road center lines down to pavement, but the conflation of the attribution is not there yet. Would this tool help do that, or is there something else?
Absolutely.
Yeah, we are doing a lot of work in conflation in general. One of the projects we're working on right now is with a product called NPM-RDS, which is a traffic product, and it requires conflation of traffic data onto the road inventory data for the entire nation. So we're conflating for the entire nation road center line, one road center line to another road center line. So it is definitely in our wheelhouse. It's the U.S. Census work we're doing. We're also, they have the the math tiger, the master address file and tiger centerline, we support the automation of that, building out that data set. So collecting data from some 3,200 different data providers and integrating that into one central database repository. So doing the change detection and conflation work of that. So in short, we just have to introduce. So
well, whoever's on the call that's listening, maybe that's Sheila. Jen Lash is
Yep, I
probably
know
worth
Jen.
have a conversation with her very soon, because we've effectively, for our research, we acquired a bunch of polygonized roads from Acopia, which is doing the 2D aerial extraction of the polygonization to fix it. But we're telling them that their road network needs to be superseded and replaced, and they're all moaning that they're going to have to do conflation and attribution. And we're saying there are companies that do that, and I think they just need to be introduced to the companies that do it. So go ahead and make that call.
We would love your support in that. We've been working on having a conversation with Jen on that same topic.
Yeah, so that definitely, because, and there's other types of conflation that we do beyond, just the linear. We can do point to linear. So like for their LRS, if they have event data that they want to plot onto the LRS, we can conflate that. We can do things, so like crash data, or like in the case of NPM-RDS, it's traffic data, traffic counts, I think. And so there's a lot. And so I will reach out to her.
I say that because I was on a call this morning, and we effectively kind of hinted at that your linear reference network sucks. We've got better lines, but how do we get your attributes onto the better lines? And that's something that they're going to try to figure out themselves. I think they're going to stumble through it. I think if someone can show them that we've got 5 or 10 different DOTs that are doing it, then I mean, there's your end. So
that's exactly what we're doing for this NPM-RDS project, is that there is a traffic vendor that they have their own linear network, and what we have to do is we have to take the HPMS data, the attribution on the basically an LRS, and conflate that onto that other network. It's exactly what you just said, Andy. It's the exact same problem.
So what is that? I'm going to say this to the rest of the group. What does that mean? That means that it sounds like TxDOT's going to be in the mode of paying money to acquire better photogrammetric data, just like the city of Austin's done, where we've got polygons from aerial imagery to figure out impervious cover and those type of entities. So now we're getting vector-based data that's better than what you've ever seen before, because it's being done from AI. The problem is it's not attributed, and that's where Kevin and folks might be able to solve the attribution issue. So that's all I got, Kevin.
Hey, Andy, I just wanted to add one other thing, is that I've recently had a discussion with Ecopia right around this same thing. So
we're all in the same boat.
That's right.
It might be all coming from the same.
I think it might. I just put 2 and 2 together in my head.
Yeah. And then, and just, another example of doing a very similar effort is with USGS. I know this is kind of off topic because we're kind of talking about GIS a little bit more, but might as well. So USGS, they are collecting new stream reach information or stream data.
The high res, the NHD high res stuff.
Right?
Yeah.
And their current conflation tools can't handle this amount of data and conflating over all the attribution onto this new LiDAR extracted stream.
Nor can the National Water Model make a conflation to their hydrofabric that they're computing with the FEM3 or FEM4 calculation. So everybody's having this problem right now. It's not roads, it's streams, it's roads, it's everything. So
exactly. So we are helping them figure out better ways to do it.
Right.
I know there's some more questions.
Thanks. That's very helpful. I'll let others talk.
We love your questions, Andy, and contributions. Thank you.
No, Andy is not with 1Spatial. Somebody asked if you're with 1Spatial. I don't know if that was a joke or.
I'm a professional engineer who's been in the consulting business for 20 something years. I retired after selling my firm, and now I work as a researcher for the University of Texas. So I know Civil 3D. I know it really, really, really well. Not as good as some people on this call, but as a byproduct, I kind of also know the GIS side world as well. So I'm in both camps mentally, maybe not professionally.
Thanks. Just share, we're working on a lot of translator projects, and I'm just hearing a lot of this right now that I'd love to follow up on with some.
Hey, Sarah, you
Wow.
kind of cut out on my end. Could you type your question in the chat bar, please?
And while we're waiting on that, I'm gonna continue on. So I have a few more slides to talk about, and then we can. I love the conversation, so let's keep the questions coming, keep the conversations going. So another area that we do more than just validating CAD drawing or validating CAD and validating GIS, we do a lot of work on integrating data sets, integrating, for example, integrating CAD to GIS. So when you're trying to do this, there's a variety of issues that typically come up. A lot of times, auto or CAD drawings are in paper space, not necessarily geographic space, so you may not have coordinates. If they are, maybe they provided like a WLD file or something like that, where there's like 2 reference points in the data set. So you still got to do a lot of rubber sheeting and so forth. In those cases, the CAD data doesn't always align to the GIS. And then even in many cases, the CAD drawing is actually more of a schematic representation, not necessarily the real world. So we help organizations try to take these AutoCAD drawings, given those challenges, and integrate those into some sort of GIS, or vice versa too. It goes the other direction too. So the example that I'm going to highlight now is an example of taking some butterfly drawings that are electrical manholes and incorporating those into a GIS, and then inferring where the feeder lines are going to throughout the entire network. So being able to basically auto-generate feeder lines from one end of the network to the other end of the network by just looking at the manhole information. So when we're doing this, the manholes themselves, they're a schematic representation. So obviously it's not like this is not the way it looks in the real world. It's closed up in a box, and these wires are running around that box. The data is in paper space. So if I put this on a map, it's going to be at 0, 0. It's going to be a null island, and so we have to figure out, well, how can we take this data set and incorporate it into the GIS? And then the other issue is that all of this information here is all just basically there's no really context to all this information. So you have to kind of infer what all of this information is. The best thing going forward is that we do have a number here that we can pull to understand which manhole it actually is, and there is a corresponding at least floor plan of the actual manhole drawing inside the GIS to incorporate these two. So basically what we do inside our rules engine is we use the information to first try to figure out, well, what are the actual objects in this drawing? So determining where the actual floor is. So once we identify where the floor is, we can also say, given that information, where are my walls? What's the banks? What's the ducts? Where's the wires? And then we can actually use the labels and the labeling information to infer what the feeder information is. So in effect, we will end up with the feeder information for all the wires, and we'll know what the manhole, we know what the floor is, so we can use that information to figure out, well, how do we get this into the GIS? So then basically we can then look at our GIS information and look at the manhole, because we know that it's not only is it in paper space, but it's also rotated in a way to make it so north is not up, right? You have to figure out, well, how does this actually fit? So what we could basically do is inside the rules engine, we're basically throwing a number of different scenarios at it. We're saying, okay, look at the manhole, compare it to the what's in the GIS, and then we keep rotating it around like 15 degrees at a time and comparing it and seeing, well, which one is the actual best match? Once we identify the closest match, we then can shift and rotate everything to all the objects in the drawing so that we actually we have the schematic representation actually in geographic space. That's the hardest part, or one of the hardest parts, right? Is getting that thing right in the general context of where it's supposed to be. From there, we then gotta and start to build out try to figure out taking the schematic and turn the schematic more into a geographic representation. So grabbing the wires and so forth and doing all that information, as I mentioned before, figuring out what the feeder ID is based off of the information that is the labels that's in the drawing. And then taking the wires and basically wrapping them around the base of the actual manhole. Now this one's not as complicated. They get a lot more complicated than this. Some like wrap around multiple times. So what we also did is we wanted to figure out, well, what was the actual distance if we wrapped it around the actual the manhole drawing. So once we do that, then it's like, okay, well, that's fine. You did it for one drawing. We have hundreds of these, right? So how do we take that and format it that so that we can apply it to hundreds? So what we did is we took what we did there, that example, we ran it on all the drawings and said, okay, well, what do we get from there? And what we found is that, yes, okay, the first time I did it, I realized I didn't take some things into account. Like, for example, the ones that are a little more complicated. So what we did was we tweaked the rules a little bit and then reapplied it. And when we did that, we were able to get about 90% of the actual manholes into the proper GIS space and also identify the feeder information and where those feeder lines actually connect to. So we can in effect generate for each individual feeder where it's the line, where it's going, and where it's coming from. So being able to infer all that information from those manholes themselves. So that was one use case. The use case of taking a schematic representation of a CAD drawing. Okay, so any questions regarding the integrating the CAD drawings into the GIS?
I guess
Andy always has something to say. So
well, I know. I guess I'm a little confused in the sense that is the ask by the client to take schematic CAD drawings and turn it into a kind of comprehensive GIS data set? Is that the intent?
I think so. The intent was to be able to understand where the wires are going, and they didn't have any of that in the GIS. So by taking the manhole information, you could see where the wires are coming and going at each individual manhole terminal or manhole place. And then you can follow the electrical lines and seeing where that where the wires are going as they're going through the entire network.
That makes sense. I guess this is probably a good time for kind of to open the floor to the others to effectively say, like, I know a lot of people in municipalities and everybody's asking for, can you take your civil 3D drawings, turn them into geospatial data to get to us in a certain schema compliant format? And some of us are doing that. Some of us are pissing and moaning about it. Some of us are not doing it. Some cities are having a bad job making it happen. I'd just be curious, like Justin's not even in Texas. So Justin's kind of fighting that in a different area. I was just curious, like, are we all doing that? Is there a tool that's missing that would help us do that?
I would say yes, we are doing that. I'm not in Texas either. I'm in Minnesota. And yes, we're doing that for our municipalities.
Are you doing that as a manual procedure, like turn the civil 3D manholes into dots and then attribute the dots, or what's the process?
Well, ArcGIS Pro handles it pretty well now. As far as civil 3D pipe networks, there's a lot of integration there, but attributing the data comes into play. And that's when it's merged in with the actual like other records, GIS records that a municipality may already have. There's some scripting and some translation that needs to go on there, and that is a manual process.
And Andy, at the city level, we're working on, connecting the FME, the CAD to the GIS part of it. So yes, but the biggest issue we have is the schema. So pretty much has to be a schema to make the transition happen back and forth, for the pipeline to work, so.
Are you taking civil 3D objects, or are you just doing 2D?
At this moment, it's just 2D legacy objects and stuff, because we're still designing 2D legacy data. The civil 3D is just, the data behind it. It's still, is background information that gives you, station, whatever, all that kind of stuff. But at the end, the guys, when we do the mapping of the data, I still do the fastest for legacy data, like, symbol or line, map it, and you're good to go. If you need to feed the data, you can get that data out of that stuff. But I mean, our workforce, rely on 2D data at the end. Even the survey that you get, like the survey, it's a 3D product. is converted to 2D product because it's faster, but just because that's the nature of the beast. The software runs faster on legacy data versus 3D data. So, but yeah, we're working on that FME. And the biggest one we have is the schema, and the city is very good on. There's the biggest issue we had, like when I started, is like the city has a big GIS data set, lots of data GIS, but do not have they don't work too well with the other users. So that's the biggest one that I have. And with the use of FME, it made it easier. And I guess since I guess he mentioned here about the taking the aligning and rotating. I was in the back of my mind, I was thinking about what about pseudo grids? I mean, the data can be stay plane, but what if the data is actually stay plane, but it's in a ground stay plane? It's a modified stay plane. How do you take that on? You still do it like a rotate, align, and scale, or you can take that data. So lots of things to play with. So
It's good to see the wheels turning in your head.
Anybody else? Justin, I know you're kind of big in this. I'd be curious to hear your instinct. Justin's having lunch. Or Adam or Courtney. I know, Courtney, you do a lot of this too. I just don't know what the procedure is, and if Kevin could have any insight from what we're fighting.
Personally, I'm all manual right now. So, the limitations of the software availabilities at work and whether or not, they want to grant access to certain users for this capability. I definitely find a big drain in my day trying to bring in GIS into Civil 3D and to get Civil 3D data out in a meaningful metadata rich format to GIS and attribute rich, right?
Mm-hmm.
So you're doing that for your municipalities and your clients. They're asking you to do that. Is that part of the contractual obligation?
Yes, sir. It's rare, but it's something that I take pride in doing well for our GIS users that get the data from us. I want to make sure that it is a well-rounded data set with proper metadata and usable attributes.
Standards come along, I guess, when it comes to maybe the city, about the submittal process of submitting data for approvals, like, it's PDF at this moment, some, CAD data sets, so that, I guess what was shown today, it would be a nice, way to approach that one, like, the requirements for submittals. But, sooner or later, we're going to move into the whole 3D submittals, Revit and all that kind of stuff. So when it gets to that point, I guess there would have to be a gateway that parses the data and spits out the compliance or non-compliance with the submittals.
I think we all see that coming.
Yeah.
Here's your land XML file for all your pipe networks. It scared me to death to give that to anybody, but I think that's an inevitability that you're going to have to do a model as a submission. I don't know when that's going to happen and what flavor that's going to come as, but I think we all see that as an inevitability. TxDOT's trying to move that way too with their roadway design stuff. Sarah, you had your hand up, so go ahead.
Yeah, thanks. Can you guys hear me okay?
Mm-hmm.
Yes.
Okay, so I am supporting a municipality right now with a inventory of their copper and lead water mains and services. And, what we get as far as data, it's, here's all the water meters, there should be 4,000, but, there's over 100,000 records because there's so many duplicates. And so the first step is, okay, well, we need to reduce this data set size and start with that. And then I guess it's kind of Ishka mentioned, it's like, okay, now we need to develop this schema. And part of it is, bringing attributes that they have in other data sets and attaching them to this data set. And then as far as I know, there's no, even though there's going to be going out there and inventorying this, I haven't heard of any talk of, going or, improving the data that they do have as far as like lines or anything like that. I think it's kind of like just attributing everything still to this point data and not taking it a step further, at least not at this time. And then with power distribution networks, I think Courtney mentioned this, it kind of becomes down to not necessarily wanting that information available to most people. So I don't think there's a push to develop it because they don't want to share it in the first place.
I think there's going to be changes.
They still want it. They just don't want to share it.
Yeah,
Trust me, they still want it.
That is true.
There's a lot of organizations that are kind of coming together, and I know New York City is one of those entities that is working on establishing a good solid underground network of utilities, you know, so that you don't have to worry about things going boom when people dig. And, you know, call before your dig is only as good as the data, right? And if they tell you, okay, here's where the thing is, and you are, you know, 10 feet off of that, you could have a problem.
Yeah, and I am working on quite a few underground construction projects right now. Actually, the past 2 months, I've worked on over 20 of them. And, you know, a big part of that, at least in the city of Boston, is a lot of those utilities are, you know, from the 60s or even 50s. And so, you know, who's going to fund going out there and locating all of these? I mean, who's going to be responsible for that?
Well, what's interesting is that I sit on a transportation research board committee, or well, I'm a part of the membership of that committee. And last summer, I was in a meeting where they were presenting the, you know, the what do you call it? The gathering of that data, or the getting of that data, using the very highly expensive and accurate ground penetrating radar, and that the DOTs, you know, work with these organizations to get that all the time, because they want to make sure where they're planning to dig, it's going to be okay. But I asked them, well, is there any effort to pull those in to, you know, some kind of a database that can be utilized for call before you dig? And he said, no, they tend to throw it away. And I was just like appalled.
And when it comes about the city of Austin, for example, data, when it comes about utility, Austin Water. Now, that one is like, last time I talked to them, it was like, you know, the data that you see in GIS, it's based on graphical location. It's not necessarily based on accurate GIS positioning. So it's like, you know, so unless the city goes and invests lots of money to get actually accurate in the GIS, you know, position, you're gonna get, you know, your manhole as good as it gets, you know.
Oh yeah, but they'll reject your plans if it doesn't match their schematic as built, though.
I don't know on that side. I'm not at that department.
I'm telling you, that's what I'm running into right now. No, but yeah, we've heard a lot, like, you know, hey, go locate this, because we're not really sure. And so it comes up as, well, you know, is this the department, utility, are they being treated differently than another one because you're requiring them to go to fund that exploration? Or, you know, if you're the utility owner, are you the one that should really be responsible for paying for that? So that's something that I've been experiencing and listening to in the construction permitting process, trying to get plans approved.
And I do want to also say, back to Kevin's point about having to clean the data a lot, because I think that, you know, let's say you're an engineering firm, and then you're the one providing these drawings. Are you responsible for having, let's say, all the water lines on the proper water layer, so that when we run them through a tool like 1Integrate, those water lines are filtered out properly? And so whose job is it to clean data? Is it the people providing you the data? Right. So that goes back to Sarah's point about, like, whose responsibility is it to maintain correct, proper, clean data, and know where things are, know where their assets are?
Should be the ones that are working with it the most, right? The utilities, it seems to me.
Well, a lot of this also goes back to data governance too, and like setting
Right.
those, like and it's, who's the owner of the data, and if they're the owner of the data, what standards they want their data to be applied to. And speaking about like, making sure that certain things on the right layers and so forth, that is something that we've done validation checks for that those types of things. Like for Google, we have to determine like, are the doors actually on the door layer? And we do that by like looking at all the objects, and do the objects actually resemble what a door would resemble? And then comparing the doors to the walls. If there's a door, then there should be a gap in the wall where the door is. So that's ways you can infer where doors should be, making sure that they are actually in the drawing itself. For something like, are the water lines on the right layer, you could actually do something like, well, let's calculate the amount of distance of water lines that are on this particular layer. And does that actually make sense compared to what our inventory says it should be? So, if it's within 5 to 10%, you're probably doing pretty well. If it's 10% or 0%, then you're missing something in that data set.
So Kevin, let me ask you, is this something, for example, if I worked at a company that just got 1Spatial and 1Integrate, would I, as the person who goes between them, would I have to do all these rule setups? Or is that something that y'all have kind of a out of the can, out of the box kind of thing for me to build on per my personal usage?
Yeah, we do. It's a lot of bit of A and B, right? In both sides, right? So we have a number of rules that, depending on what the industry is, we have a number of rules already developed for that particular industry, or that particular solving those particular problems or validating those particular data sets. Typically, we find that we may do services work on top of that to help you build out your rule sets to meet whatever needs you need to do. Or we also provide training to train you on how to, like, okay, here's some example rules that are going to get you, maybe 50 to 60% of the way there, maybe 80% of the way there, depending on how similar your problem is to what other people we've worked with in the past. And then from there, you can learn you can build your own rules and expand on that to be more specific to your particular use cases. So it's we provide software, we also provide training, we also provide services on top of it too, just depending on what your needs are and what your challenges are and how complex your challenges are.
Thank y'all so much. Really appreciate all the 1Spatial team for being here today. Andy, if you wanted to cut the recording, or no, Adam, sorry, Andy already left.